Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on binomial distribution. And we're in the middle of an example on brown cows. If you have not watched part 1, you will need to do so to figure out where we're picking up, because we're picking up exactly in the middle of a problem. And at this point, we are now looking at 2 brown calves, and the number of ways to have 2 brown calves is 10. And you can sit there, I'm not going to read out those, but as you look there, you can see that there are multiple ways to have 10, or there are 10 ways to have 2 brown calves. And then we have the individual probabilities that go along with those. Notice in each of those there are 2.9s multiplied by 3.1s. The order is different in each of those, but guess what? Just as before, these equal the same thing. If we multiplied them out, they would be 0.00081. So all of those are equivalent to the same thing. And again, we have 10 of those. And how could we figure out how many there would be? Would be to think of it as how many ways are there out of 5 to pick 2 places to put the bees. And the order of the bees would not matter, so it is a combination of 5 choose 2, and that would give us 10. And again, going from the bottom back up, if we added 10 of those, we get 0.0081. We could get that by saying 10 times 0.00081. Notice that just moves the decimal when we added those. And that is 10 times 2.9s and 3.1s, or 10 times 0.9 to the second times 0.1 to the third. And the 10, because we have 10 of those and we're multiplying, the 10 comes from the 5 choose 2. And this is how we're developing our formula. And I'm hoping that you are beginning to see some patterns here that are developing. The next possibility we have, and we will look at, is having 3 brown calves. And this would be 3 brown calves and 2 calves that are not brown. And again, we have 10 possibilities for these. And they are listed there in the first column. Again, I'm not going to read all of those out. Emphasizing here the pattern that we have, which would be 3 brown calves gives us 3 probabilities of 0.9 multiplied by 2 probabilities of 0.1, the probability of not being a brown calf. And the order is different for each set, but the numbers are exactly the same. And when we multiply those out, each of those multiply to be 0.00729. How can we tell how many there are? Well, again, how many ways are there to place 3 brown cows in 5 slots? That would be 5. It would be a combination of 5 choose 3, which would give us 10. And we would have 5 choose 3 times 0.9 to the third times 0.1 to the second. Notice that there are 5 total cows we're looking at, so that 3 plus 2 would give us 5, or 10 ways, 0.9 to the third times 0.1 to the second, 10 times 0.00729, or 0.0729. Next, we will look at having 4 brown calves and 1 not being a brown calf. Notice this only gives us 5 ways to do so, and the individual probabilities are listed. Notice as we list those, there are 4 0.9s, but only 1.1. 4 brown calves gives us 4 0.9s. 1 not brown calf gives us 1.1. And the number of ways to do that, or excuse me, the individual probability then gives us 0.06561. The number of ways to do so, or to have arrangements of this, is a combination of putting the 4 brown cows into 5 slots. So that would be 5, choose 4, which is 5. And we have our probability at the end of a total of 0.32805, which is 5 times each of the individual probabilities of 0.06561, which is 5 times 0.9 to the 4th times 0.1 to the 1st, and the 5 again comes from the 5 combination 4. Lastly, the last possibility we need to look at is having all brown calves. There's only one way to have all brown calves, and that would be 0.9 times 0.9 times 0.9 times 0.9 times 0.9, and how many ways are there to do that? That would be 5, choose 5, which is 1. And that would be 0.59049, or 1, and we'd have 0.9 to the 5th and 0.1 to the 0, because there are 0 not brown calves. And then we have this top line here as well. So let's kind of stop here and review and create our probability distribution. We have the probability in our notation here, the probability that x equals 0, the probability that x equals 1, the probability that x equals 2, the probability that x equals 3, the probability that x equals 4, and the probability that x equals 5. Notice our notation, a capital P, then inside the parentheses what we're looking for, x equaling. The first column is the number of brown calves possible out of 5 calves born. We could have 0, we could have 1, we could have 2, we could have 3, we could have 4, or we could have all 5 of the calves being brown. We will put the formula, or that top line of each of those screens that we looked at, in place, and I'm going to do so now. And as you notice that the first is the count, or the number of ways we could have, or arrangements that we could have, of the number of calves. For 0 there was only one way, but the way that we counted that was to do 5 choose 0. The number of ways to figure out that there were to have 1 calf was 5 choose 1. The number of ways to figure out to have 2 calves was 5 choose 2. The number of ways to have 3 calves was 5 choose 3. The number of ways to choose 4 calves was 5 choose 4. The number of ways to choose for 5 calves was 5 choose 5. Notice where the 5 comes from. The 5 is the total number of calves. The second part of your choose is the number that we're looking for. The 0 matches the 0, the 1 matches the 1, 2 matches 2, 3 matches 3, 4 matches 4, 5 matches 5. Next, notice the probabilities. With 0 brown calves, we have 0.9s in our formula, and that means we have 5 not brown calves, or 5.1s. Notice where the 0 comes from, and where the 5 comes from. In the next formula, we have 5, choose 1, so we know where those numbers come from. The 0.9 is to the first power because we have one brown calf. If one of our calves is brown, how many are not brown? Well, that would be 5 minus 1, or 4. If we have and are looking at 2, we know where the 5 choose 2 comes from. We know that we have 2 brown calves, so we know where the 0.9 to the second comes from. So where does the 0.1 to the third come from? Well, if we have 2 brown calves, 3 of the calves are not brown because there has to be a total of 5 calves. 5 minus 2 leaves us 3 left. Again, now looking to x equals 3, that would be 5 choose 3, 0.9 to the 3, because there would be 3 calves that are brown. The probability of being brown is 0.9. That leaves 2 cows not to be brown, or 5 minus 3, so that we have the rest of the cows not being brown. Now to probability of x equaling 4. 5 choose 4, 0.9 to the fourth times 0.1 to the first. 4 brown cows plus 1 that's not brown gives us the total of 5. And for x probability of x equaling 5, we have 5 choose 5 times 0.9 to the fifth, because all 5 of the cows are brown. That means there are no cows that will be not brown, so that would be 0.1 raised to the 0 power. And this is a good place to stop. And I hope that this has kind of explained some of the things. We're just getting started on the binomial distribution, so please stay tuned or turn over and watch the next video in this part. And this does conclude part 2 of this set. Thank you for watching.